name is Jamie.
My name is Madison.
Today I will be covering the commutative property of multiplication.
I will be covering the associative property of multiplication.
So the commutative property, you can change the order of the numbers, but your answer will always stay the same. And the numbers can commute with each other, switch up, but they'll always be the same. And an example is, oh my God. An example could be 7 times 2 because it's 7 groups of 2, which equals 14. Or you can switch it up. And you can do 2 groups of 7, which equals 14, and they're always the same, even if you change up the order.
Transitioning into associative property, this one uses grouping and groups certain chunks of the problem together. This property states that the grouping of numbers in a number sequence can be changed around and you will still get the same answer as what you would if you had gone forwards instead of backwards with the grouping. So your example could look something like this. If you have 3 times 5 and those two are grouped together, and then you also have a times 7, it is the same thing as if you were to have 3 times the grouping of 5 times 7. So the only thing that changes around is your parentheses here and there, but either way you're still going to get the same answer. So because of order of operations, you have to do your parentheses first. So you take your 3 times 5 here, which you get 15, and then 15, you bring your 7 down, times 7 is going to equal the same thing as your 7 times 5, which brought down is 35, times, bring your 3 down. These two are going to equal the same thing. So your 15 times 7 and your 3 times 35, which would end up being 105 and then 105. And as you can see, those two are equal. That is one example. We'll get into another example with a little bit bigger numbers, so you can see that it really, or with more numbers than just 3, and you can see how changing around the parentheses really doesn't affect your problem. However, the numbers in your number sequence do have to all be multiplication. So if I were to have like an addition sign or a subtraction sign or a multiplication sign in an addition problem, I couldn't do it because all of your signs have to stay the same. So for another example of different numbers, you could have 148 times 72 times 4 times 8. And if your parentheses are here, it is the same thing as if you were to have 148 times 72 times 4 times 8 and have your 4 and your 8 grouped together. So for this one, you will end up getting the same thing over here, grouping the two bigger numbers together as you would over here, grouping the two smaller numbers together. So you'll jump back over here and you'll get 10,500, or sorry, not 500, 656. So it'll look like that. And then you'll bring down your 4 and bring down your 8. So you'll have times 4 and times 8 left, which will equal this, which is 32. So you bring that down here. So 32 times 72 times 148. And as we already know, this group together is 32. So you bring that down times what you got over here, which is 10,656, equals your 32 that you'll bring down. And then what you got from over here on this one, your 10,656. So then, since all you have left are your two numbers, you will just multiply them together, and you can see that it will already equal the same thing, which is a pretty big number, 340,992. So then 340,992. So those are your examples for that. Both of these properties can only be done with addition and multiplication. You cannot use subtraction or division. These two properties do not apply to them at all. So if you try and group like a 7 minus 2 together, you're gonna get a different answer than when you, and then there's also a like minus 4 on the other end of that. You're gonna get a different answer if you do 4 minus 2 minus 7, if that makes sense, because you're not subtracting or dividing in the same order, because your numbers decrease instead of increase is part of the issue with that. So those two properties do not apply at all to subtraction or division. They're only to be used on addition and multiplication. Thank you.